Okay, so here we have another product rule question, and I think this time it's fairly obvious what u and v will be. U will be the first parentheses. So u, let's say, is 3x minus 8 to the power of 7. So if you differentiate there, du dx, or u prime, whatever you want to call it. Okay, this is, if you remember the chain rule, when you have a power on parentheses, multiply down by the power, 7 times 3x minus 8, and reduce the power by 1 to the power of 6, by the derivative of what's inside. The derivative of 3x is, 3, I'm thinking too far ahead, which you can then, if you want to, you can combine the 3 and the 7, but let's not do that right now. Maybe later on we'll see that there is a value in it, but for now we'll just leave it the way it is. So 4x plus 9 to the power of 5 is the other factor, v, so dv dx. Okay, multiply down by the power, 5 times 4x plus 9, reduce the power by 1, so that's the power of 4, and then multiply by the derivative of what's inside. The derivative of 4x plus 9 is just 4. Again, we could go 4 5s or 20, but we'll just leave that for the time being. Okay, so now going back to dy dx. dy dx, okay, is u dv dx plus v du dx. The first, ux minus 8 to the power of 7, by the derivative of the second, so u by dv, so which is 5 by 4x plus 9 to the power of 4 by 4, so that's u by dv dx, now plus the second, 4x plus 9 to the power of 5, by the derivative of the first, du dx, by 7 times 3x minus 8 to the power of 6 by 3. Okay, so what we're going to do here is we're going to look for the greatest common factor in these two terms. And they each contain 3x minus 8, and they each contain 4x plus 9 to the power of 5. So we'll be, 4x plus 9. So we'll be able to pull some of those out. Now it is differentiated already, but we can make it a little bit neater looking. So 3x minus 8 to the power of 7 in this one, 3x minus 8 to the power of 6 in this one. Bring the smaller of those two out. So 3x minus 8 to the power of 6. Okay, we added to the power of 7 here, to the power of 6 here, you bring the smaller one out, so 3x minus 8 to the power of 6. You also have 4x plus 9 to the power of 4 here, and 4x plus 9 to the power of 5 here. So again, bring the smaller one out, that's 4x plus 9 to the power of 4. Okay, now those are going to be the greatest common factors, so let's see what we have left. In this, we had 3x minus 8 to the power of 7, and we pulled out 3x minus 8 to the power of 6. So that means we still need one more. So for the first term, we still need one more of these. We then had 5 times 4 times 4x plus 9 to the power of 4. We pulled out the 4x plus 9 to the power of 4, so we pulled out all of that, and we have 5 times 4, which we can make now 20. Okay, then plus, now we had 4x plus 9 to the power of 5. We pulled out 4x plus 9 to the power of 4, which means we still need one more. So that's 4x plus 9. And out of this parentheses, we pulled out the 3x minus 8 to the power of 6. We pulled all of that out, which leaves us 7 times 3, which is 21. Okay. So we're going to have 3x minus 8 to the power of 6 times 4x plus 9 to the power of 4. And that's all going to be multiplied by 20 times 3x is 60x minus 160 plus 21 times 4x is 84x plus 189. Okay, so we can simplify what's in those square brackets, and we're going to have 3x minus 8 to the power of 6 times 4x plus 9 to the power of 4 times 60x plus 84x is 144x, and minus 160 plus 89 is plus 29. Okay, and we can't simplify it any more than that. So dy dx is equal to 3x minus 8 to the power of 6 times 4x plus 9 to the power of 4 times 144x plus 29. Again, just to reiterate, it was already differentiated at this point. That was the differentiation, but for multiple choice purposes, you will be required probably to factorize it as much as possible and to simplify what's left. So you should be able certainly to get it to there, but also you really need to be able to take it to here to allow for what you might see in a multiple choice question. Okay?